All right, everyone. So last class we started talking about the basics of probability and how probability is essentially the likelihood that an event will occur. We used words like this. We talked about impossible being a 0% chance, certain being a 100% chance, and that, we can show probability as percents, like I just discussed here. We can also show them as fractions and decimals ranging from a value of 0 to 1, right? So 50% and these 1/2 and 0.5 means that it's equally likely to happen or not happen, or as likely as not. And anything kind of in this range is unlikely, and anything in this range is showing likely, right? Impossible and certain are much harder. They require exactly 100% to be certain, exactly 0%. Unlikely, there's this big range. Same thing with likely. But we'll usually use different adjectives to describe it, like very unlikely if it's down at 5% or something like that. Even 99% is like close to certain, or almost certain, or extremely likely. So we use some different variations on the words than just what's up here. So we're going to go ahead and get a little bit more advanced now and talk about actual probabilities. So we're going to take a look at something called experimental probability and theoretical probability. And so I'm dealing with this thing right here where it's the, it says the basic version. So I have this watermark. So let me go to this different, there you go. I have a picture right here, so that way we can see these without having them be cut off. So I want to actually talk about theoretical probability first. On your paper, it's the second one on that page. So if you could turn to page, let me just confirm, I believe it's page 3. Let's check it real quick. Actually page 4. So on page 4, you'll see actually it talks about experimental probability first, and it gives you that. But I want to talk about theoretical first. So theoretical probability is, in theory, what you expect to happen. This is likely the probability that you already know about and have some experience with, right? When you roll a die, what do you expect to happen? Okay, so the formula for that is the probability of the event. This is kind of the formatting for how we write it. We'll write P, okay, uppercase P, and then in parentheses we'll write down whatever event we're referring to. I'll show that again here in a second. And the fraction is going to be the number of favorable outcomes to making that event occur over the total number of possible outcomes. So for instance, if I wanted to do, it said to get a 5 on a 6-sided number cube, right? So the formatting for how we'd write that is the probability of getting a 5. And so what we're going to do is we're going to make a fraction. And let's see, on a 6-sided number cube, well, the total number of possible outcomes are 6 total possible outcomes. And the favorable outcomes to getting a 5, well, that would just be getting a 5, right? So there's just one single outcome that would be favorable to this event. So this would make us 1/6 as a probability, and we can also do that as a decimal, and we have it as fraction. So decimal as a percent. This would end up being 0.1, let's say 7, 6 repeating, but 1/7 in terms of a decimal, or 17, 17.7 or 17.8, I guess, repeating percent. So just to kind of give you an idea of what this kind of looks like, we'll just say, 18% for the sake of it. Okay, cool. So that's the one. Now that's theoretical probability. I talked to you about how this is something that you're probably more familiar with. So now let's get to experimental probability. We talked about this a little bit last class. We just called it a different name. We called it relative frequency, right? And there was the one where we were shooting a basket. Actually, here we're going to actually be talking about the same one. Actually, I think this is the exact same numbers that we used last class too. So I think this is on page 2. So this is probability based on a number of trials, right? When we shoot a basketball, it's not equally like it's not the same odds for every single person, right? When we roll a die, it doesn't matter who's rolling it, the likelihood of it coming up on a 5 is the same. So experimental probability is when we take events and we run a trial first and say, okay, well, on the bottom I'm going to have the total number of trials, and on the top I'm going to have the number of times the event occurred that we're talking about. So if here it says you made 7 out of 10 baskets, what's the probability of making the next basket? Well, in total, we shot 10 times, and we made 7 of them. So 7 is the favorable to what we're talking about here, making the next basket. And so yeah, that's 7/10. It could be 70% or 0.7. So I'll write that as well. 0.7 or 70%. There's different formats for how we write it. But leaving it as a fraction is totally fine when we write our answers. All right, so let's move back to our presentation. So let's go ahead and check out the examples. We'll try to apply these to a couple problems that are on page 4. Okay, so like I said, the top one is talking about experimental probability first. So we'll do that first. So we'll leave this up here. This is kind of just telling our formatting. And let's go down here. Give me a second. I'll put it in red. Okay, so it says finding experimental probability. The table shows the result of spinning a spinner 50 times, right? What is the experimental probability of landing on an odd number? So again, we want to go ahead and use this formula where it's the total number of trials on the bottom and the number of times the event occurred. So now take note, spinning a spinner, right? Spinning a spinner numbered 1 through 4, we could use some theoretical probability for this, right? Because, we could say, oh, hey, well, there's 4 things that could occur, and maybe we want to talk about it landing on 2, right? Well, okay, there's 1 opportunity for that. So 1/4 is the theoretical probability, in theory, what we expect to happen. But that's not what it's asking here. So we could also run these experiments into experimental probability on, things that have the same odds. So what we're going to do is we're going to go ahead and say, well, the total number of trials, well, so let me change this. So probability of, let's see, landing on an odd number. So I'm going to say probability of odd based on our trials. Well, the total number of trials that we had were all of these together. We spun it 50 times. If you add these up, it'll add to 50. So 50 total trials. And then the number of, what's the word, favorable things that for odd, well, 1 or a 3 would work. And let's see, we did that 13 times and 17 times. So in total, if we add those together, that would be 30 times. So 30 of our 50 rolls or spins came up as odd or favorable to this odd event. So if we simplify that, we'd say 3/5. So there's a 3/5 chance for that to occur, which comes out to 60%. So yeah, I like to put it as a percent often, so you can just kind of rationalize what that looks like. Oftentimes we'll be able to comprehend 60% better than we will 3/5. But leaving it as 3/5 is perfectly fine. All right, let's take a look at our next one. This one's talking about theoretical probability. Down below, you'll see these tiles here with the 4 letters EACH, so each. So we're going to use theoretical probability. It says you randomly choose one of the letters shown. What is the, let's assume it's from a bag. What is the theoretical probability of choosing a vowel? So here's our formula. So let's say probability of a vowel. Again, this is the formatting for how we write probability. Well, the total number of possible outcomes, well, I could pull an E, I could pull an A, I could pull a C, I could pull an H. So all 4 of those are possible outcomes. Now it said, now on the top is the number of favorable outcomes. Well, we're talking about choosing a vowel. Well, E is a vowel, A is a vowel, C is not, H is not. So that's 2 of the 4 possible outcomes that are a vowel or favorable. So, we're going to simplify that to 1/2 or 50%. And that's that. All right, let's keep going. Let's look at the next page. On page 5, it's going to be asking us to be comparing the theoretical probability to the experimental probability. So in this situation, let me make this actually a little thinner, it's a little bit thick. All right, so it says, the table shows the results of spinning a spinner 100 times. All right, if you add all these frequencies up, it should add up to 100. How does the experimental probability of spinning a 5, so spinning a 5 is what we're talking about, compare to the theoretical probability? So this is a pretty good question. So I'm going to leave it like this for abbreviation, and we'll do experimental right afterwards. Okay, so in theory, right, that's the one where we take the total number of outcomes that you can get and put that on the bottom. So there's 5 total outcomes. And getting a 5, well, there's only 1 of those that could be a 5. So we're expecting 1/5, which comes out to 20%. Okay, if we're spinning it 100 times, well, that means I'm expecting probably 20 of these. If we expanded this fraction, we multiplied both the top and the bottom by 20 to make it out of 100. But what we'd see is 20 out of 100, right? So we're expecting that out of 100 spins, we would get 20 of really each of these. And as you can see, that's obviously not the situation, right? We know that odds are not always going to end up the way that they would appear with our probabilities. The more times you run the trial, technically, the more likely it is to get closer to these numbers. Kind of like flipping a coin, you could flip it maybe 10 times. You might come up at 8 times as head, 2 times as tails. The more times you flip it, the closer it's going to get to that 50-50, that true theoretical probability. So again, it didn't happen that way. So let's go ahead and do the experimental probability for this. So in this situation, we're looking right here. We know that we ran this trial 100 times, and we came up with 25 of them were favorable for a 5. So if we simplify that, that comes out to 1/4. You can also see here it's 25%. So that's kind of the comparison that shows that they were a little bit different. The experimental probability in our case came out to 25%, whereas the theoretical was 20%. Okay, and again, we could leave these as fractions as well. All right, what I'm going to say is go ahead and pause the video. I want you to go ahead and try this one on your own, where you're again comparing the experimental probability to the theoretical probability for each of these events according to our table and the spinner that's shown right here. Then you can unpause the video and you can see kind of the answers and what I do here. All right, hopefully you've done it already, so let's go ahead and do this. I'm going to kind of speed through it a little bit. So probability of spinning a 7, I'd like to do theoretical first. So spinning a 7, well, there's one thing here out of 8, so there's 8 total possible outcomes. One of them's a 7, so 1/8. Spinning a 3 or a 6, so once again, there is still 8 total possibilities. A 3 or a 6, well, there's 2 of them, so that would simplify to 1/4. I don't know if you could hear my cat meowing, but he's kind of going crazy. Spinning a number less than 5. Well, let's see, less than 5, that does not include 5. So that means 4, 3, 2, and 1. So there's 4 of them out of still our 8 total possible outcomes. So that would be 4/8, and that would simplify to 1/2. And then not spinning a 2. Well, not spinning a 2, that's really everything other than 2. So we know that, again, of the total 8, there are 7 of them that are not a 2. And that can't simplify at all, so we're going to leave that. So these are our probabilities here. Experimental now. Okay, well, these are our frequencies that we spun. Take note, we spun 25 times. So all my denominators are going to be 25 because those were the total number of trials that I had done. So we'll put that down. All right, so spinning a 7. Well, we spun a 7 2 times. So I'm going to go ahead and put 2 as my numerator. That cannot simplify, that's done. Spinning a 3 or a 6. We spun a 3 5 times, a 6 5 times. That's going to get us a total of 10, and I know that can simplify to 2/5. Yeah, that's right. All right, spinning a number less than 5. Well, that would be these ones right here. So I'm going to go ahead and take the 3. Oh, actually, I'm going to do the 5 and 5 is 10, plus another 5 from the 3 and the 2 is 15. So 15 over 25 for the numbers that are less than 5. That'll simplify to 3/5. And lastly, here we go, not spinning a 2. So again, that's everything except for the 2. Well, instead of adding these all up, I know I spun 25 times and 5 of them were 2, so let's inverse that to kind of take it away. So these must add up to 20 times that we got not a 2. So you can kind of do that reverse logic often, and that's going to come out to 4/5. Okay, so yeah, that's everything. You're going to work on the next page as classwork, and then if not for homework. But hopefully you are understanding the idea, the difference between theoretical probability and experimental probability. Theoretical is what you expect in theory to happen. It's more like odds, sorry, down here. And then experimental probability is based on some trials that you've run previously, to collect that data.